Moving on to the fifth question. Given that secant theta is equal to 13 by 12, calculate all other trigonometric ratios. Now moving on to the solution. He has given that secant theta is equal to 13 by 12. So let us consider a right angle triangle in which theta is the base angle, and let us designate the sides as x, y, and let hypotenuse be z. Now we know that secant of an angle is equal to hypotenuse by adjacent side. Here the hypotenuse is nothing but z, and the adjacent side of angle theta is y here. Now this can be got equated to secant theta, but he gave the secant theta value as 13 by 12. Therefore, as z by y is equal to 13 by 12, let us assume that z is equal to 13 and y is equal to 12 in the simplest form. Now, in order to find all other trigonometric values or trigonometric ratios, we need to find the other side, that is x. Now, by applying the Pythagoras theorem to the triangle, we get z square, that is hypotenuse square, is equal to sum of squares of other two sides, that is x square plus y square, which implies z square here is 13 square, which is nothing but 169, that is equal to x square plus y square, which is nothing but 12 square, that is 144, which implies x square is equal to 169 minus 144, that is nothing but 25. As x square is equal to 25, we get x is equal to root of 25, which is nothing but 5. So we got the values of x, that is equal to 5, and y, which is equal to 12, and z is equal to 13. Let us find the all other trigonometric ratios. First of all, coming to the trigonometric ratio, that is sin theta, which is equal to, we know that sine of an angle is equal to opposite side by hypotenuse. Here it is opposite side is x by hypotenuse is z, which is equal to x is 5 and z is 13. And cos theta is equal to, we know that cos of an angle is nothing but its adjacent side by hypotenuse. Here the adjacent side is y and the hypotenuse is z, which is equal to y is 12 and z is 13. And let us also find the tan theta value, which is equal to, we know that tan of an angle is equal to its opposite side by adjacent side. Here the opposite side is x and adjacent side is y, which is equal to x is 5 and y is 12. Now let us also find the value of cot theta, which is equal to, we know that cot of an angle is equal to its adjacent side by opposite side. Adjacent side here is x, adjacent side here is y, and the opposite side here is x, which will be equal to, the y is 12 and x is 5. And also let us find the value of cosecant theta, which is nothing but the inverse of sin theta. Therefore cosecant theta can be written as 1 by sin theta, which is equal to 1 by sin theta value is 5 by 13. So 1 by 5 by 13 is 13 by 5. Moving on to the first sum. In triangle ABC, right angle at B, AB is equal to 24 centimeters, BC is equal to 7 centimeters. Determine sin A, cos A, sin C, cos C. Moving on to the solution. Let us consider triangle ABC, which is right angled at B. Here AB is equal to 24 centimeters and BC is equal to 7 centimeters. Let us also find the hypotenuse AC. From Pythagoras theorem, we know that the square of hypotenuse is equal to sum of squares of other two sides in a right angle triangle, which implies AC square is equal to AB square, which is 24 square, plus BC square, which is nothing but 7 square. That implies AC square is equal to 24 square, which is nothing but 576, plus 7 square, which is nothing but 49. That will be equal to 576 plus 49 is nothing but 625. That implies as AC square is equal to 625, AC is equal to square root of 625, which is nothing but 25. Therefore, we got the hypotenuse as 25 centimeters. Now, in the first problem, he asked us to find the value of sine A. We know that sine of an angle is equal to opposite side by hypotenuse, which is equal to opposite side is BC here by hypotenuse is AC here. That is equal to BC is given as 7 centimeters and AC is given as 25 centimeters, which is equal to 7 by 25. Now, he also asked us to find the cos A. Here, we know that cos of an angle is equal to adjacent side by hypotenuse, which is equal to, here adjacent side is AB for angle A and hypotenuse is AC, which is equal to 24 centimeters by 25 centimeters. That is equal to 24 by 25. Now moving on to the second bit. He asked us to find the value of sine C. We know that sine of an angle is opposite side by hypotenuse. The side opposite to angle C is here AB by hypotenuse is AC, which is equal to 24 centimeters is AB and 25 centimeters is AC, which is equal to 24 by 25. Now he also asked us to find the value of cos C. That is equal to, we know that cos of an angle is adjacent side by hypotenuse. Here the adjacent side of angle C is BC by the hypotenuse is AC, which is equal to BC is 7 centimeters by AC, that is hypotenuse 25 centimeters, which will be equal to 7 by 25 is the cos C. Moving on to the fourth question. Given that 15 cot A is equal to 8, find sin A and secant A. Now moving on to the solution. Let us note on the given information that 15 cot A is equal to 8. That implies cot A is equal to 8 by 15. Let us assume a right angle triangle with A as base angle and B 90 degrees and C be the other vertex of the triangle ABC. In this, he has given that cot A is equal to 8 by 15. We know that cot of an angle is nothing but the ratio of its adjacent side by opposite side. We can write cot A as the adjacent side of A, angle A is AB here, by the opposite side of angle A here is BC, which is equal to 8 by 15. So here we can write AB as 8 and BC as 15. Now in order to get sin A and secant A, we need to find the value of AC, the hypotenuse. Now by applying the Pythagoras theorem to triangle ABC, we know that the hypotenuse square is equal to sum of squares of other two sides. Here we can write AC square is equal to AB square plus BC square. That implies AC square is equal to AB square, that is 8 square, plus BC square, that is 15 square, which is equal to 8 square is 64 plus 15 square is 225, that is equal to 289. So here we get the value of AC as square root of 289, which is equal to 17. So AC can be written as 17. Here firstly he asked us to find the value of sin A. We know that sine of an angle is equal to opposite side by hypotenuse. Here is equal to the opposite side of angle A is BC and hypotenuse here is AC, which is equal to BC is 15 and AC is 17. And in the second part he asked us to find secant A. We know that secant of an angle is equal to its hypotenuse by the adjacent side. So here the hypotenuse is AC by, and adjacent side here is AB for angle A, which is equal to AC is 17 and AB we got it as 8. Therefore secant A is equal to 17 by 8.